And now I said before that my exchange agency doesn't charge any fees when I go and do that. That's not quite true, because what actually happens is you need a lot of energy. That's why we're at Cern, in fact. Where does all this energy come from? It comes from accelerating something. At Cern, we mostly accelerate protons. So you accelerate protons, I've given them a lot of kinetic energy. Now you want this kinetic energy converted into antiprotons somehow. What do? You do the basic things that physicists have done since forever. You smash it into something. Okay? So you smash these protons into a target, and then it's up to nature to decide what happens. We don't have very much control after that. Because when a proton happens to smack into something, lots of things can happen. It can make all kinds of mesons and quarks and pions and whatnot. And there's a competition between all these processes, and we have no influence on this competition. And unfortunately, this competition says that you need about 1 million protons to make one antiproton. Because most of the time, nothing interesting happens, or at least nothing we want happens. And there's not much we can do.
Minkä takia tuonne Cerniin ei rakenneta omaa isoa tietokonetta laskemaan hiukkaskiihdyttimen esimerkiksi FLITS-K-tietokonetta?
Tuo on tavallaan niin kuin tosi hyvä kysymys siinä mielessä, että jos tämä koko homma pitäisi suunnitella nyt ihan alusta alkaen, niin mä voisin melkein suositella sitä. Mutta tämä koko niin kuin fysiikkatöiden niin kuin alkuperäinen analyysihomma, niin sehän aloitettiin jo tuossa 90-luvun puolivälissä. Ja tuolla alakerrassa on aika sellaisia hyviä taulukoita siitä, että miten silloin niin kuin ajateltiin tuon tietokoneen laskentakapasiteetin ja erityisesti datakapasiteetin niin kuin, tulevaisuutta esimerkiksi tänne 2012 vuoteen, mutta alun perin tämän koko homman piti alkaa tuottaa dataa jo vuonna 2008, eli sen massiivisen konekapasiteetin piti olla saatavilla silloin 2008. Ja kun sitä projektoitiin silloin 90-luvulla, niin tämmöinen hajautettu homma niin kuin kuulosti aika järkevältä. Ja nythän meillä on niin 120 paikallista laskentakeskusta, joissa jokaisessa on tuhansia CPU:ita jauhamassa tätä, niin tätä niin tavallaan valmiiksi kehitettyä infrastruktuuria on aika vaikea.
Information, maybe this there is an effect, is because it can change the cloud properties. I mean, if you have, let's say, 1, 2, 3, 4, 5, 6 aerosol, you make this kind of cloud. Now imagine there is a process which changes the numbers of these particles. You can produce more of them. Then you emit a cloud as well, but with much more particles inside. Okay, but you still have the same amount of water. Then you will make a cloud, which will get much more brighter because you make very small cloud droplet instead of big one. You make a very white cloud, and then you reflect more light to the space. And also you increase the lifetime of a cloud, because it doesn't want to precipitate so fast. And just because you change the numbers of seeds. Okay? And we try to understand this mechanism. Now, how we produce that one.